Hello, everybody. All right, so here is the sheet that you guys are working on right now. It's just a practice sheet. You guys are given one in class. We went through that all together. Here's some practice problems. You can find it on Canvas. Of course, you know that if you've made it to this video. Anyhow, here are the instructions. Here's problem one. I'm going to fly through these rapid fire, and you can follow along with me, or you can just download the answers and check your work. Of course, remember you can always pause and replay parts if you're curious why or how I'm doing what I'm doing. Okay, magnesium plus oxygen makes magnesium oxide. If it's by itself, it's just plain old magnesium. Oxygen is O2 because it's one of our diatomics. You should know this one. Magnesium oxide is Mg, which is plus 2 if it's bonded. Oxygen is minus 2 if it's bonded. So those guys neutralize each other. That's a perfectly fine formula. However, I've got a balancing act now. I've got magnesium and oxygen. Magnesium and oxygen. There's not enough room here. One magnesium, two oxygen atoms, one magnesium, or one oxygen atom. So I need to put 2 here. No, that's not what I need to do. Sorry. So I need to put 2 here, which gives me 2 oxygen atoms. This equal that. That also gives me 2 magnesiums because it's 2 MgOs. So I have to go over here, give myself 2 magnesiums to make it even. So that's a 2:1 to 2 ratio. 2 magnesiums plus 1 oxygen molecule makes 2 magnesium oxide molecules. Although really it's a formula unit because it's ionic. Okay, here's the next one. Mercury 2 oxide turning into mercury and oxygen. All right, mercury 2. Mercury is Hg. What's that Roman numeral mean? It means it's plus 2. Oxide is O. What's the charge on oxygen? -2. The oxide ion, that is, neutral. Good. Breaks down into mercury, Hg. Does this have to be a pair? No, it's not one of our diatomic elements, so it's just Hg. Plus oxygen. Does this have to be a pair? Yes, because it's one of our diatomic elements. So, pile them up. Some mercury, got some oxygen, mercury, some oxygen. By the way, I've blown this up to be 200%. You can make it bigger if you're having trouble seeing this. One mercury, one oxygen, mercury, 2 oxygens. Same deal. 2 over here, 2 oxygens, but it also gives me 2 mercuries, so I have to put a 2 there. And I'm done. 2 mercuries. 1. All right, moving on. Carbon plus oxygen makes carbon monoxide. Carbon, if it's by itself, plus oxygen, I put 2 there because it's diatomic, pure and unbonded. Makes carbon monoxide. Mon means 1 oxygen. Boom. Carbon got some oxygen. Carbon got some oxygen. One of those, 2 of those, one of those, one of those. That's not right. So we put a 2 there. I have 2 oxygens, 2 carbons. Over here, oxygens are good, carbons are bad. We put a 2 there. There you go. Why don't I put it there? Because you can't add subscripts after you've got everything neutral. Carbon plus oxygen makes, in this case, carbon dioxide. Notice carbon and oxygen making 2 different compounds with different properties entirely. This is what you create and breathe out. If you breathe it in little bits, it's not a big deal. This, if you breathe it in, it makes you dead in bad amounts. So different things because they have different combinations. Carbon, oxygen, those, 2 of those, 1 of those, 2 of those. Hey, it's balanced. They have 1, 1, 1 ratio. Oh, up here it was 2, 1, 2. All right. Hydrogen, it's diatomic. Don't forget it. Oxygen, diatomic when it's by itself. Mix water. You better know that's H2O. All right. H's got some O's. H's got some O's. H's, 2 O's. 2 H's, 1 O. That's the problem. There's a 2 there. That gives me 2 O's. All right. But it gives me 4 H's. So we got to fix it over here. Put a 2 there. Now I've got 4 H's. Everything's good. We've got a 2 to 1 to 2 ratio. Let's refresh our memories. That 2 comes from there. That 1 comes from there. That 2 comes from there. All right. How you doing? You hanging with me? Remember, you can always pause and rewatch parts if you need to. All right, here's the opposite. This is if you electrolyze water, you can turn it back into hydrogen and oxygen gas. Problem is it takes a lot of energy to do that. We'll learn later that you have to put a triangle onto that to indicate that you're adding energy to the system. 2 H's, 1 O, 2 H's, 2 O's. Dope. Go over here, 2 there, 2 O's, 4 H's, 2 there, 4 H's, 2, 2, 1. All right, pay attention to this. Check it out. The ratios are in slightly different order, but it still all checks out. Same numbers. All right, moving on. Okay, carbon dioxide or methane and water. CH4, which is methane, plus oxygen makes carbon dioxide and water. This is what we talked about today. This is a hydrocarbon. Adding oxygen means you're burning the hydrocarbon, making carbon dioxide and water. So it's going to be a challenge. They always are. C H's and O. C H's and O. 1 carbon, 4 hydrogens, 2 oxygens. 1 carbon, 2 hydrogens, and 1, 2, 3 oxygens. We're going to leave the oxygens for last. Let's fix the hydrogens. Got 4 here, 2 there, 2 here, so 2. 4 hydrogens. Awesome. How many oxygens do I have? 1, 2, 4. I've got 4. Can I fix this? I need 2 more oxygens, so 2 there. Need 4. Hey, check it out. We did it. 1 to 2, 1 to 2. All right, aluminum by itself, what's the charge? Trick question, 0, no charge. There's nothing to give its electrons to or take them from, so it's 0. Adding oxygen. There it is, diatomic again. Don't you forget it. And we're making aluminum oxide. What's the charge on aluminum? We look at our periodic tables and see it's +3, or 3 plus. Oxide is -2. So what do? We Al2O3. If you don't understand what I just did there, go back and look at the video from yesterday, the one on assigning charges. All right, let's back to this. Have some aluminum, have some oxygen, some aluminum, have some oxygen. 1 of those, 2 of those, 3 of those. Oh boy. All right, what do we want to fix first? Let's fix the aluminums. Let's put a 2 here. Done. Don't. No, now I got to get the oxygens right. Okay, I have 3 here, I have 2 there. Where are they going to meet? They're going to meet at 6. I'll put 3 here, which gives me 6 oxygens. So I'll put a 2 here, which gives me 6 oxygens. All right. Oh, but wait. Now my aluminums are messed up because I have 4 aluminums. I have to go fix this. Let's get rid of that guy. And instead, let's call that 4 aluminums. 4 aluminums, 6 oxygens. 4 aluminum, 6 oxygens. We have a 4 to 3 to 2 ratio. All right. You hanging with me? Still going? Sodium and oxygen. And A plus O2 makes NaO. Sodium by itself, it's fine. Oxygen, diatomic, because it is. Sodium oxide, the charge in sodium is +1. Oxygen is -2, so you've got to go Na2O to make that neutral. All right, well, we have some sodium, have some oxygen. Have some sodium, have some oxygen. Counting atoms here. 1 of those, 2 atoms there. 2 atoms of sodium, 1 atom of oxygen. Oh boy. Well, let's fix sodium. 2. Done. No, wait, not done. Oxygens are bad. So let's put 2 there. 2 oxygens. Gives me 4 sodiums. So here we are again. Boop. Let's put a 4 in there. I've got 4 sodiums. 4 of those, 2 of those, 4 of those, 2 of those. Looks good. 1, 2. This guy. All right, sodium oxide. We just saw that. That's Na2O plus water H2O makes sodium hydroxide. Where have I heard that before? Oh yeah, it's one of our polyatomic ions you've memorized, right? All right, what's the charge on sodium? +1. Charge on hydroxide, -1. Is that neutral? 1 sodium and 1 hydroxide? You bet, that works. All right, so we've got some sodium, we've got some oxygen, we've got some hydrogen. Squeeze that in. We've got some sodium after, some hydrogen after, some oxygen after. 2 sodiums, 2 hydrogen, 2 oxygens. Sodium, 1 hydrogen, 1 oxygen. Oh, how about if I do that? Oh, done. 1, 2. Wait, where are those numbers coming from again? 1 is from there. Remember, if there is no number, it's assumed to be a 1. This one is from there. Remember, there's no number, so it's a 1. 2, there's a 2 drawn there, so we know that. All right, just about there. Go thinner. Sodium plus H2O. You saw that. Remember when I dropped those chunks of sodium in water and exploded? Here's what got made. Sodium hydroxide, 1 minus 1, that's neutral, plus hydrogen. Do we like it like that? No, we do not. It's diatomic. It's one of the 7 we need to remember. All right, some sodium, hydrogen, some oxygen. Sodium, some hydrogen, some oxygen. 1 of those, 2 of those, 1 of those, 1 of those, 3 of those, 1, 2, 3, and 1 of those. Oh boy. All right, which one do you fix? Let's fix the hydrogens. We've got 2 over here. We've got 3 over there. Let's put a 2 here for ourselves. 4 hydrogens and 2 oxygens. So I need to fix my oxygen situation. So I'll put a 2 there, which gives me 2 oxygens. All right. But what's it do to my hydrogens? Now I have 2 hydrogens plus 2 for a total of 4, and I have 2 sodiums. My oxygens are good, my hydrogens are good, my sodiums are not. So I'll put a 2 there. 2. Everything's groovy. Sulfur by itself doesn't need a 2. What's its charge? No charge because it's by itself. So oxygen makes SO2. I am not going to entertain the notion of balancing that because it's so simple. SO2 makes SO3. Now we've got to work with. Some S, got some O. Some S, got some O. 1 of those, 2 of those, 3 of those. Nope. All right, we know if we get the 3 and 2, we're shooting for the number 6. Let's put a 2 there. Give ourselves 2 sulfurs, 6 oxygens. Put a 3 there. I'm sorry, a 2 there. Just 2 sulfurs. And let's put a 3 there. It'll give us 6 oxygens. Clean that just a little bit. And fix it again. Remember, I'm putting a 2 there. So that's 2, 3, 2. You guys are doing great. SO3 sulfur trioxide plus H2O. Somebody might say, wait, isn't that sulfite? It would be if it had a charge, but it doesn't have a charge, so it's sulfur trioxide. All right, moving forward. We're going to make hydrogen sulfate, SO4 minus 2, you remember? Hydrogen's plus 1, so we need 2 of those there. H2SO4. All right, got some S, got some O, got S, got some O. 1 S, 1, 2, 3, 4 O's, 2 H's, S, 1 O's, 4's, H, 2. All right, wait, we're done? There you go. Straight up combination reaction where everything just kind of piles up on top of each other. All right, so 1, 1, so 1. Nice and easy. Nitrogen and 2 diatomics plus hydrogen and 2 one of the diatomics makes nitrogen tetrahydride. And H's. And H's. 2 of those, 2 of those, 1 of those, 4 of those. All right, let's shoot for 4. Oh wait, let's fix the N's. 2 over here, 2 over there. Now our hydrogens just went to 8. Can you believe it? All right, so our nitrogens are good, our hydrogens are not, so put 4 there. Now we're good. 1, 4, 2. Hydrogen, H2. Fluorine, Cl2. Remember, it's one of the 7 that start on 7 and look like a 7, including hydrogen. The diatomic elements. Cl. What's chlorine's charge? The chloride ion? Oh yeah, -1. Is that good like that? You bet it is. It's also known as hydrochloric acid. This one, I hope you can start looking at it and recognizing how straight up this one is. Done. If you're not sure, you can work it out on your own.